Good morning, students and viewers. Welcome to my YouTube channel, The Diligent Coaching Seminary. It is an academic YouTube channel in which I upload different tutorial videos based on the courses of schools and colleges. Today, once again, I have come here with the new video, and today I have come here to give you the lecture for class 10 students in the subject of science. And in the subject of science, I have been giving you the lecture of the chapter 4 in my previous 8 videos, and today I have come here with the 9th part of the 4th chapter. And before to start my today's tutorial, I want to request all the students and viewers, please kindly subscribe my channels and press the bell icon such that whenever I bring any tutorial videos for you, then you will get the notification. And also I want to request to you, please like, share and comments in the videos. And if you want my lecture in the particular topics of the particular subject and particular level, then you can mention that in the comment box such that I can address your request and I can bring the necessary lectures to you. Now I want to request all the students to watch the video completely and get the benefit for your study. From my previous video of part 8 of the chapter 4, I have started to give you the lecture on the necessary numerical problems which can be asked in your examination, and I am going to continue the same lecture in this part as well, and I am going to discuss some other numerical problems which is necessary for you. And let's start to see the numerical question. And here is one numerical question I want to explain to you. If mass of the earth is 6 into 10 to the power 24 kg, mass of the moon is 7.2 into 10 to the power 22 kg, and the distance between earth and the moon is 3.6 into 10 to the power 9 meter, and the gravitational force of attraction between the earth and the moon is 2.2 into 10 to the power 18 Newton. Calculate the value of G. So in this question, mass of the earth m1 equals to 6 into 10 to the power 24 kg. It is given. Mass of the moon m2 equals to 7 into 10 to the power 22 kg. It is also given. And distance between the earth and the moon, that is d, equals to 3.6 into 10 to the power 9 meter. It is also given. And the gravitational force of attraction F equals to 2.2 into 10 to the power 18 Newton given. And here we have to find out the value of the universal gravitational constant G, and it can be found out by using the formula of the gravitational force. And first of all, gravitational force F equals to G m1 into m2 by d square. You know, this is the formula obtained from the Newton's universal law of gravitation, and we have to find out the value of capital G here, that is universal gravitational constant. So let's write G equals to F into d square by m1 into m2. It is obtained from this step to this step by the law of equation. So G equals to F into d square by m1 into m2. It is the required formula to us, which is obtained from this main formula. Now we can put all the values here because we know all these values. And value of F is 2.2 into 10 to the power 18 Newton, and d square means 3.6 into 10 to the power 9 whole square, and m1 is 6 into 10 to the power 24, and m2 is 7.2 into 10 to the power 22. Then now we have to see in the another step, and in the second step now in the place of 2.2 into 10 to the power 18 we have written as it is, and now here is 3.6 into 10 to the power 9 whole square is here. So first of all we have to do the squaring of both, and we have to do squaring of 3.6 and 10 to the power 9, because here is 3.6 into 10 to the power 9 whole square. So 3.6 whole square, it is obtained 12.96, and 10 to the power 9 square is 10 to the power 18. So it is obtained, and denominator is written like this. Here we have written the numbers together, 6 into 7.2 numbers together, and 10 to the power 24 and 10 to the power 22 together, because you know we have to write numbers together and 10 to the powers together. Then again in the numerator we have written numbers together, 2.2 and 12.96 together, and we have here 10 to the power 18 and 10 to the power 18. So we have to add 10 to the power 18 plus 18 according to the law of indices. And now in the denominator here, 6 into 7.2 is obtained 43.2, and 10 to the power 24 and 10 to the power 22 is here. So here also power should be added, and 10 to the power 24 plus 10 to the power 22, it is according to the law of indices. Now here you can see by multiplying 2.2 into 12.96, it is obtained 28.512 in the numerator, and here 10 to the power 18 plus 18, it will be 10 to the power 36, and in the denominator 43.2 into 10 to the power 46 written as it is. Now here once again we have to separate the numbers together and 10 to the powers together. So we have written 28.512 upon 43.2, numbers separate, and 10 to the power 36 upon 10 to the power 46 together separately. Then to 28.512 upon 43.2, it is obtained 0.66 here, and you can see 10 to the power 36 and 10 to the power 46, you know you have to subtract 10 to the power 36 minus 46, and 10 to the power 36 minus 46, it will be 10 to the power minus 10. So we obtain here 0.66 into 10 to the power minus 10. And to write in scientific notation, we have to shift the decimal to right side, that is we have written here 6.6, and you know 6.6, and when we shift the decimal to right side, then negative power should be increased. This is the rule. And so we have written here 6.6, and in the place of 10 to the power 10, now we have to write 10 to the power 11, because when we shift decimal to right side, then negative power should be increased. And this is the required answer, and it is the required answer, required value of the universal gravitational constant Z. Therefore the value of universal gravitational constant is 6.6 into 10 to the power 11. Now let's see another numerical question, and you can see the numerical here. Mass of the Jupiter is 1.9 into 10 to the power 27 kg, and that of the Sun is 1.99 into 10 to the power 30 kg. If the distance between the Sun and the Jupiter is 7.8 into 10 to the power 11 meter, calculate the gravitational force of attraction between them. So in this question you can see mass of the Jupiter m1, it is given, and mass of the Sun m2, it is also given, and distance between the Jupiter and the Sun, it's given here, and we have to use the value of the universal gravitational constant G. We know that now gravitational force F equals to what, and now we have to use the formula of the gravitational force. Simply we know F equals to G m1 into m2 upon d square. We know this formula, and we have to put all the values. Value of G is 6.67 into 10 to the power minus 11, value of m1 is 1.9 into 10 to the power 27, value of m2 1.99 into 10 to the power 30, and d square means 7.8 into 10 to the power 11 square. Then now in the numerator we have written all the numbers together and 10 to the powers together, and so we have written here 6.67 into 1.9 into 1.99 together, and 10 to the power minus 11 into 10 to the power 27 into 10 to the power 30 together. Now in the denominator again we have to do the squaring of both 7.8 and 10 to the power 11, because here is 7.8 into 10 to the power 11 whole square is here. So we are doing the squaring of both, and 7.8 square is 60.84 obtained, and 10 to the power 11 square is 10 to the power 22. It is obtained here. Now in the another step, by multiplying all these numbers, 6.67 into 1.9 into 1.99, it is 25.219, and you know we have to add all these 10 to the powers according to the law of indices. So it is obtained 27 plus 30 minus 11, And now in the denominator we have written as it is 60.84 into 10 to the power 22. Then now here we have to write numbers together and 10 to the power together again, and 25.219 upon 60.84 it is separate, and 10 to the power now 27 plus 30 minus 11 it is obtained 10 to the power 46, and in the denominator 10 to the power 22. So 10 to the power 46 upon 10 to the power 22 together. Then here by dividing this 25.219 upon 60.84 it is obtained 0.414, and into 10 to the power 46 minus 10 to the power 22 should be done according to the law of indices. Then here we obtain 0.414 into 10 to the power 24 Newton. And again we have to write by scientific notation, and this decimal should be shifted to right side. And because you have to know to write in scientific notation before decimal it should be exactly one digit. So we have written 4.14, and when we shift the decimal to right side then positive power of 10 should be decreased. So we have written 10 to the power 23. The positive power 24 is decreased by 1, and it is obtained 4.14 into 10 to the power 23 Newton. It is the required answer. Therefore the gravitational force between them is 4.14 into 10 to the power 23. Now let's see another numerical question, and the numerical is like this. An object having mass 40 kg is attracted by the object of mass 60 kg by 4 into 10 to the power minus 5 Newton force. Calculate the distance between them. So in this question here it has given mass of the first object m1 equals to 40 kg given, mass of the second object m2 equals to 60 kg also given, and gravitational force of attraction is given 4 into 10 to the power minus 5 Newton, and we have to use here the value of the universal gravitational constant g equals to 6.67 into 10 to the power minus 11, and distance between those objects equals to what it is asked, and it can be calculated by using the formula of the gravitational force. We know that the gravitational force F equals to g m1 into m2 by d square, and now we have to find out the value of d square. So let's keep d square separate, and according to the law of equation d square equals to, we obtain here g m1 into m2 upon f. Now it is the required formula we have to use. Now we can put all the values here because we know all this value of the right side, and the values are substituted like this. Value of g is 6.67 into 10 to the power minus 11, value of m1 is 60, value of m2 is 40, and value of f is 4 into 10 to the power minus 5. And now here we are writing all the numbers together and 10 to the power together. Number 6.67 into 60 into 40 upon 4 together separately, and 10 to the power minus 11 upon 10 to the power minus 5 together. And by simplifying this part we obtain 4002, and into 10 to the power minus 11 plus 5 should be done here according to the law of indices. Then here we obtain d square equals to 4002 into 10 to the power minus 6, and now d equals to root under this part 4002 into 10 to the power minus 6, and now we have to do the square root of both, and the square root of 4002 is 63.26, and the square root of 10 to the power minus 6 is 10 to the power minus 3, and we obtain here 63.26 into 10 to the power minus 3. And again to write by scientific notation, before decimal 1 digit, and after decimal we have to write digit. So we have to shift this decimal to left side by 1 digit. So here we have to write 6.326, and when we shift the decimal left side then negative power should be decreased. So we have shifted the decimal left side by 1 digit, so we have to decrease the negative power of 10 also by 1. So we have written here 10 to the power minus 2, and it is meter because it is the distance, and it is the required value 6.326 into 10 to the power minus 2 meter, and it is the required value of the distance. Therefore the distance between those objects is obtained 6.326 into 10 to the power minus 2 meter. So it is the required answer. Now let's see another numerical, and another numerical question is like this. the numerical is the gravitational force produced between two objects is 10 Newton when they are placed between the distance 40 meter. Calculate the gravitational force between those objects when they are at the distance of 100 meter. Here we have initial gravitational force F1 equals to 10 Newton and initial distance between them D1 equals to 40 meter. And question has said what is the gravitational force when those objects are at the distance of 100 meter. So final distance between those objects is taken 100 meter, and now for the required gravitational force is final gravitational force between the objects F2 equals to what, and we have to use this formula here. We know that F2 by F1 equals to D1 square by D2 square. It is the required formula you have to use in this question. And now we have to find out the value of F2. So F2 will be, it will be D1 square upon D2 square into F1. So here in the place of D1 square 40 square, D2 square is 100 square, and into F1 is 10. This is the value of F1. Then now you know 40 square it will be 1600 and 100 square it will be 10,000. First of all 0 0 will be cancelled, and after 0 0 cancel, now what will remain here? It will remain and here 2 0 also will be cancelled here. This 0 and this 0, this 0 and this 0 also cancel, and in the numerator 16 will remain, and in the denominator 10 will remain. And F2 equals to 16 by 10, it is 1.6 Newton. Therefore the required force of attraction between those objects is 1.6 Newton in the second case. Now let's see another numerical question, and question is like this. The gravitational force between two objects is 45 Newton when they are placed at the distance 100 meter. What should be the distance between them such that the gravitational force between them is 300 Newton? Now in this question also it is same as the previous question. The initial gravitational force F1 is given 45 Newton, and the initial distance between them is given 100 meter. The final gravitational force is 300 Newton, and now what should be the required final distance? And we have to use the same formula, F1 by F2 equals to D2 by D1 whole square, D2 square upon D1 square. And from here we can write like this, D2 square by D1 square equals to F1 by F2. And you know we have to find out the value of D2 square, so let's write D2 separately, and here we obtain D2 square equals to F1 by F2 into D1 square. It is by the law of equation. Now we can put all the values, and F1 equals to 45, F2 equals to 300, and D square means D1 square means 100 square. Then 45 by 300 into 100 square is, you know, it is 10,000 obtained, and here D2 square is obtained exactly 1500 by simplifying this term. It is obtained 1500, and you know now D2 equals to, it is root under 1500, and value of root under 1500 is 38.729 meter. So therefore the required distance for the gravitational force is 38.729 meter. So it is the required distance. Now let's see the next numerical question, and the question is like this. If the weight of an object is 500 Newton at the surface of the earth, at how much distance away from the center of the earth the weight of the object is 200 Newton? That means at the surface of the earth weight is 500 Newton. So at how much distance away from the center weight is 200 Newton. So it also should be done by similar ideas as previous question. Here initial weight of the object is 500 Newton, radius of the earth is 6.4 into 10 to the power 6 meter. So it is a value of W1 and R1, and now the required weight, that is final weight of the object, W2 equals to 200 Newton. Then final distance between the objects from the center of the earth, R2 equals to what? Now we have to use this formula here, W1 by W2 equals to R2 square upon R1 square. And we have to find out the value of R2 square here. So R2 square separately, R2 square equals to W1 by W2 into R1 square. It is by the law of equation. Then now we can put all the values here, because we know all these values w1, w2 and r1, and here you know w1 equals to 500, w2 it is 200, and r1 square is 6.4 into 10 to the power 6 whole square. And by cancelling these two 0, then we obtain 5 by 2 only, and here we have to do the 6.4 square and 10 to the power 6 square both, because here is whole square of 6.4 into 10 to the power 6. So 6.4 square is 40.96, and 10 to the power 6 square is 10 to the power 12. And now what we have done here is you can see here simplifying this term, 5 by 2 into 40.96, it is obtained exactly 102.4 and 10 to the power 12 as it is. And now it is the value of r2 square, and you know r2 equals to, it should be done under root, that means square root of 102.4 into 10 to the power 12, and the square root of 102.4 is exactly 10.119, and square root of 10 to the power 12 is 10 to the power 6 meter. So square root also can be done separately here. Then it is obtained 10.119 into 10 to the power 6 meter, and it is the required distance. The required distance from the center of the earth is 10.119 into 10 to the power 6 meter for that gravitational force. Now the next numerical question, which is important for you: a man can lift 100 kg at the surface of the earth. How much the person can lift in the Jupiter? Now in the earth, first of all, mass of the object m equals to 100 kg, and acceleration due to gravity g equals to 9.8 m per s square. Now weight of the object equals to mg, you know it is the formula of weight, and it is weight of the object is obtained 980 Newton. Now in the Jupiter, how much weight the person can lift in the earth? The person can lift same weight in the Jupiter. That is the concept you have to know. And since the person can lift 980 Newton weight in the earth, the person can lift exactly this much weight in the Jupiter. So weight of the object in the Jupiter also 980 Newton. That is the weight the person can lift. And acceleration due to gravity in the Jupiter is 25 meter per second square. And now here again w1 equals to m into g1, w equals to mg formula. And now by the equation we obtain m equals to w1 by g1, that is 980 by 25, and it is obtained here, you can see in your screen, 39.2 kg. So 39.2 kg is the mass that the person can lift in the Jupiter. So this is the required answer. Now next numerical: an object is dropped from certain height and reaches the ground in 4 seconds. Calculate the height of the object from where it was dropped. This is the question. And now let's see the solution. Time taken to reach the ground, t equals to 4 seconds, and acceleration due to gravity g equals to 9.8 into 8 meter per second square. You know this is the average value of g. Then height of the object h equals to what? And now here you have to use the formula h equals to 1 by 2 gt square. This is the formula of height when the object is falling freely. And now let's put all the values, and 1 by 2 gt square, then putting all the values, g equals to 9.8 and t square is 4 square, and 4 square is 16, and you know 2 is divided by 16 and it will be 8, so it will be 9.8 into 8, and 9.8 into 8 multiply will get 78.4 meter. It is the required height of the object. Therefore the object was dropped from height 78.4 meter. So students, these were all the necessary numericals question which can be asked in your SCE examination and other your internal examination from the chapter 4s, and I hope you will prepare all these numericals, and you can pause the video and note down whatever numericals you want to note in your copy. And now I want to just give you this much lecture for today in this video, and in fact this is the end of the 4th chapter of class 10 video. And I want to request once again all the students, please kindly subscribe my channels and press the bell icon, such that whenever I upload any new necessary tutorials for you, then you will get the notification and you can get benefit for your study. And I also want to request you to like and share my videos through your social media. And I also request you, if you need the lecture on the particular topics of particular subject of particular class, then you can mention that in the comment box such that I can see your requirement and bring the required tutorial videos to you. So I want to end my today's lecture, the ninth part of the fourth chapter. We will meet in my upcoming videos. So till then, all the students and viewers, stay blessed, and thank you very much for giving me time. Goodbye.